Very good morning to all of you. Are we all ready? So before our telling fine, I guess just small introduction about the course and then we'll start, right? Though this course is completely on laptop only, but maybe for half an hour to 45 minutes we can come out of laptop and later on we can do. Okay, so can we switch off the laptop? Means remove the laptop for half an hour. As the term is operation, research and management science, this entire means concept of operation research is not a very old one. It originated somewhere. Good morning. It originated somewhere during the Second World War period. Now you must be wondering that in Second World War, somewhere around 2000 mathematicians were hired. In a World War II, 2000 mathematicians were hired to win a battle. You must be wondering that how a mathematician can help to win a battle. Because what happened during war, there are a lot of arm and armaments are there which need to be moved from one place to another, which are very bulky, too much weight is there, and the places are very remote one, very difficult to. So then the help of these mathematicians were taken that they used to give a proper trajectory and a proper path and at what angle things need to be moved, so that entire process became more smooth. Secondly, what used to happen to meet any one particular target, earlier somewhere around 4,000 bullets need to be showered to reach a target, means that used to be the one hitting one in 4,000. So you can imagine how much amount of arm and armament used to get wasted. So that is why these mathematicians were hired at how they can optimize the entire process. But after World War II, what happened that nowadays we don't have war. So then those 2000 mathematicians who were hired, they were jobless. So they started thinking that using our mathematical algorithm, if we can win a war, why can't we win in a business? So they started applying those technique and those concept in business. So that is how the term is operation management. So operation war, research when they started applying in business, but now this terminology has changed. The new books which are coming, so after all, afterward they started using these concepts in their day-to-day management. So the title changed to management science. So you can see your title also operation research and management science, but the new textbook which are coming up, they have changed the name further and they have made it as a more a decision making tool. It is one of the most integral decision making tool which is used in every organization for optimization. In every walk of life it is being used extensively. So we'll see that how we can use a tool for optimization in our organization, in our work, right? Though this complete course will be on Excel only, it is an Excel based tool. This course is being taught to engineering graduate as well and management graduate as well. So when we teach to engineering graduate or those who are doing MSc, then we explain the concept, means the algorithm. The method is chosen of algorithm, how to get an answer. But when we use it in a business, then we don't follow the algorithm rule. We will be using a software which is an inbuilt Excel tool, Excel solver, and our means entire understanding will be application oriented rather than going into how the calculation happen, because calculations are too long. If we want to solve these questions which we will be doing, it may take one question to solve 2 hours. So that is why it is completely a different one. So you don't have to go into the algorithm. Being a management graduate, it is more of application, and when it is there for MSc, then we teach in other way. Same course taught in different ways. Are we ready? Now, okay. So I just request IT department to do it, right? Pardon? Okay. Is it okay now? Is it okay now? No? Now is it okay? Can we increase a bit more? Good morning, how are you? I think maybe in 5-10 minutes even my volume will increase. So we'll have to lower it down. Okay, right? The first chapter, which if you have seen the curriculum, we'll start today with the linear programming. The first session will be on linear programming, first and second. Then in the third session, we enter into more deeper concept of linear programming, that is sensitivity analysis. In this way, we have 3 days are there, n number of topics will be there. And exactly in the same way, 2 means you can imagine the entire paper can be divided into 3 parts. So whatever we are covering will become one part, whatever we cover tomorrow will become the second one, and whatever we cover in the last day will become the third one. So means 2 question, 2 question, 2 question. In this way, if there are 3 are there, so 3. In this way means a simple way to explain how we'll go ahead. So we are starting with the term linear programming. Can we come out of laptop for some time? Ms. Arva, please. Have you heard about the term linear programming? There is one term which is a linear programming, another is a non-linear programming. So when we are talking about a linear programming, we are talking about a linear function. And when we are talking about non-linear programming, we are talking about a non-linear function. Now what is a linear and what is a non-linear? For example, if I am manufacturing any stuff, right, anything I manufacture, if 5 units of raw material A is required to manufacture 1 unit of the product, for 2 units I will require 10 units of raw material, for 3 I require 15 units of raw material, right? So the raw material is increasing exactly in the same way the number of units are increasing, means the progression is a linear one. But in another scenario, for example, if you're working, if a person is working, then what will happen? As he keep on working, then then the skill of the person keep on getting improvised. So after a certain time, what will happen? The same quality of the product he can manufacture in a lesser amount of time. So you can see initially what was there, the raw material or any effort which is required to manufacture a product, it is going exactly in the same linear fashion, that is a linear programming. And if there is a change is there, if the time increases or decreases, whatever it is, then the curve cannot be a straight line, it will be a curve. Initially it was a line, now it will be a curve. So when it is a line, it is a linear function, it is linear programming. And when it is not a linear one, is it okay if there is a curvature is there, it becomes a non-linear one, right? In linear programming, what we'll do right now is there are certain amount of resources will be there, and utilizing the resources, we are required to manufacture a product, or we are required to complete any activity, or we are required to accomplish any task, right? So to accomplish a task, to complete or to manufacture a product, we require certain ingredient. So how best you can utilize the ingredient so that with a minimum amount of raw material you are able to achieve your target, right? Our objective is what? If I'm manufacturing something, I need to manufacture, that is an objective. And secondly, being a business graduate or a business professional, obviously your objective will be that how you can accomplish the task with a minimum amount of resources. So when you accomplish a task with a minimum amount of resources, then what will happen? It will impact your profitability, am I right? So what will happen? You want to enhance your profit, you want to maximize your profit, that is your objective. And what are the limitation and what are the constraints are there? Because raw material will always be limited. It won't happen that you are having abundance of raw material. If you are having abundance, then the problem won't arise. The business issues are there, that the resources are scarce. Whatever the material is, that will always be a scarce, whether it is a human resource or any physical material. So how best we are able to utilize our resources, that's what we are required to learn in linear programming in a simple language, right? So when a problem will be given to you, for every problem, For every problem, you are required to identify two issues. One will be objective. What is objective of your problem? What is objective of the issue? If it's something you want to manufacture, your objective will be to maximize the production. If you are dealing in a profit, your objective will be to maximize the profit. If you are dealing anything in the cost, then you like to minimize your cost, right? If revenue is your objective, you like to maximize your revenue. So the first thing, you are required to read the problem and identify whether you want to maximize or minimize. Initially, the problem will revolve around these two only. Either it will be a maximization or it will be minimization. And secondly, what will happen, you are required to identify what are the resources available and what you have to do with the resources. Please. There will be certain constraint will be there, because as I am telling you that the resources are always limited in nature. So when the resources are limited in nature, then that is a constraint for you. Is it okay? So two things are there. One is your objective, another is a constraint. In every problem, you are required to identify what is your objective and what is your constraint. And this entire curriculum, not even the topic right now, is it okay? I'll teach the entire curriculum in such a way that hardly we will be using any formula. Maybe one or two technical formulas will be there which you have to remember, but otherwise complete course we'll try and understand. It is complete thinking, nothing you have to remember. So how intelligent way you can think to identify, and in every problem only two things need to be identified. What is your objective and what are your constraints? Are we ready for it? Sometimes it may be there that there are some interrelated issues are there, which as we progress, then we let you know that if there are more than two objectives are there, how to achieve them, right? Definitely, that will be the major one. But what will happen, these top line and bottom line are associated with n number of intermediary issues. So how we can combine them together? Really a very interesting course. One of the most important course which is used in industry right now, extensively in every walk of life. And what I have done is, rather than keeping as an operation, I have applied in marketing, finance, each and every walk of life in a easy layman language, right? Are we ready? Let us take it forward. The sheet which I am using it up on the blackboard, but let me work on it for one or two more. Mr. Rohan, is it visible on that side? Sir, is it fine? Miss Yashashvi on this side, is it okay? So let us start with a very simple and a basic problem. Let me work on the problem for some time. So can I request you to come out of the laptop, please? Though the complete course is on laptop, you will have to do simultaneously, but at least I can explain you the basic concept first, then we take it together, right? I have put most of the data in the Excel format so that you don't have to punch the data. You can lift it and straight away transfer on your sheet. But at some point of time, you will have to punch the data as well. Shall I read it? I won't explain you the basic one, what is linear programming in the language. You'll understand from the question. And as we go ahead toward the second or the third one, I'll go into more deeper into it. That is a sensitivity analysis. Each and every word you'll understand. Let us take it forward. A Marriott tub company manufactures two lines of batter, Model A and Model B. Every tub requires a certain amount of steel and a zinc. The company has available a total amount of 25,000 pounds of steel and 6,000 pounds of zinc is available. Each model of the batter A require a total of 125 pounds of steel and 20 pounds of zinc. So what is given to you right now? A company is there in the manufacturing of batter. There are two types of product are available, that is Model A and Model B. In order to manufacture, you require two ingredients, you require two raw material. that is steel and the zinc. These are the two things which are required. I have a limitation, I have a constraint that only 25,000 pound of steel is there. If I was having abundance of steel, then I could have done anything. I don't have any problem. But since there is a limitation, there is a concern that I don't have more than 25,000 a pound of steel and 6,000 of zinc. Now, then secondly, one more information is given that how much profit you will be able to get if you manufacture barter A, and how much profit you will get if you manufacture barter B. Are we ready with it? It is simple problem right now. So let me write this information. Yeah. So we have a model A, and then we have a model B. It is given profit per unit. How much profit is there for product A? $90. And for this one, 70. Now we require two raw material. One is steel and second is zinc. What is the maximum amount of available two quantities? How much amount of zinc is available? 6,000 unit of zinc. Steel is available and so we have 25,000 unit of this one, 6,000 unit of this one. One more information is given per unit how much amount of raw material is required. How much steel is required to manufacture 1 unit of barter A? 125. On this side, 20, 130. Is it okay? The complete information I can put it in a form of a table, right? Now, as I told you that you are required to find out what is your objective and what are your constraints, what are your limitations. So as far as objective is concerned, definitely profit is given to me. I like to maximize my profit. And I think that is also written that find out the best production mix. Production mix will be what? Wherein I can get the maximum profit. So the only concern for me is how many unit I want to manufacture. So I'm using a term DV, that is decision variable. How many unit I need to make for this one? How many unit I want to make for this one? That is Y. As of now, I'm not aware about it, how much A and how much B is required. So I'll just take any guess in any number X and Y. Are we okay with it? Right? So Shiv Kumar, Mr. Rohan, will you like to join in the first row? You are comfortable there? Sure, comfortable? Okay. Let me write my objective then. Now, objective I'll represent by a notation Z. And Ms. Bindu, in this one Z, what will happen? My objective will be to maximize. So what will be your maximum profit? If you manufacture X unit of A and that is giving you a profit of $90. So can I write down my equation as 90x plus 70y? All of you agree to me? Are we okay? Now I write down my constraints. So I have a constraint for steel. I have a constraint for zinc. So who will help me to write an equation? Mr. Mohit, can I request you to take it forward? How can I write the equation for steel? Okay, okay. Any Mohit, take care, you can. Both. So it will become 125x, perfect, 125x plus 100y. Now over here, rather than equal to 100, because it is not essential that I will be able to utilize all the raw material, because there are two raw material are there which need to be taken simultaneously to manufacture the product. But I cannot overuse it. I don't have more than 25,000. So my consumption should be either 25,000 or less than 25,000. Am I right? So can I write down this one should be less than or equal to 25,000? Similarly, I can write down the second equation as 20x plus 30y should be less than or equal to 6,000 units. That is how. So when every problem is given to you, you are required to read the problem, identify what is your objective, identify what is your constraint, put your objective and constraint in a mathematical form. Mathematical form means in a form of an equation, and then we have to find out the solution for that, right? To find out the solution, there are two methods are there. One is a graphical method, which is always taught, means being taught as the first one, but I'll just skip that one. That is not applicable for you because only two conditions, only two constraints are there. Then if there are more than two constraints, then these doesn't work. So we will have to follow a solver method, because in a business definitely there won't happen that only one or two constraints are there. That is taught to the junior classes. Are we okay? So let us take it forward that how solver as a tool will help you. So one question I'll do with you first. Solver. Yeah, I'll let you know how to bring the solver on the desktop. Everybody has a solver with you in the Excel. It is an Excel inbuilt function, but you'll have to bring it on desktop. So I need your attention now. Can I request you to please come out of your laptop? All of you? No, you'll have to come out of your laptop, please. So we need to request you to please. Yeah. I can lift this table as it is. Okay. First of all, within data there will be a solver, you can see, but if you have not used solver till now, it won't be shown. So you'll have to go on the top, that is a file or a office button, whichever you have. Go to file. Then you will find there is an option. We will do simultaneously. So right now you may just see what I am doing is. So you have to go to option. Then you will find that there is an add-in function. And within this you have a solver add-in. After doing this one, you will have to say go. So it will get added within your add-in. Put a tick mark. Just put a tick mark and say OK. And you will find that within data, the solver will be there. Are we ready? Okay. Let us solve the problem. First one, I'll write down decision variable. Decision variable is represented by dv, which I wrote over here, dv. When you are writing on a paper, when you are doing on a paper, you will have to use it as x and y. But when you use in a solver, it won't work with x and y. You will have to put any number. But these numbers are dummy numbers. We follow a convention. We follow a convention that decision variable always, Mr. Siddharth, we'll put it in a blue. There is no rule for it, but the convention is being followed in all the textbooks. Is it okay? So that what happened when you are solving the question, right now it is a very small one, so fine, you will remember. But when the questions are very complicated, is it okay? There might be multiple decision variable, and if you don't put it in a blue color, you may forget it. So just for that one, for the convenience, this rule has been accepted. Now, how many unit of A and how many unit of B I need to manufacture? Initially, what will happen? I am not aware about it. So I'll just put any dummy number. So anything, maybe I need to manufacture 10 unit of this one and 20 unit of this one. Are we okay? Fine. I write down over here one term, that is usage. I write objective over here. I can put my objective. Okay, what will be your objective? What you did was x into 90 and y into 70. That is how you got your objective. Ms. Janki, the same thing I'll do it over here. So this is my x and this is my y. This is profit 90 and this is profit 70. So can I write, I want to multiply this 10 with a 90 and 20 with 70. Do you agree with me? Now, if you see what I'm telling, two things I need to do. First, I need to multiply the two things together and then I need to add them. So two functions are working simultaneously. But since we are working on an Excel, is it okay? Why should I do it two times? I must be having a function where both the things can be done simultaneously. So Kian, first I need to multiply, then I need to add. So there is a function in Excel which is known as a sum product. So it will do product and then it will do sum simultaneously. So I use a function is equal to SUMPRODUCT, open a bracket, sum product of these two numbers multiplied by these two numbers. All of you agree to me? So as I told you, Ms. Arva, as I told, the first thing is you are required to put your objective in place. Then I have done it. Now you are required to play around with your constraint. So what are your constraints now? Same thing I do it. Sir Akhilesh, will you take it forward? Now, so what I need to do is, I need to find out if I manufacture 10 unit of this and 20 unit of this, how much amount of steel will be consumed? How much steel will be consumed? Is it okay? This number times this number times this number. Agree with me, right? Next to Mr. Akhilesh, can I request you to put your name tag, please? Okay, may I know your name? Shashank. And sir, what about you? Sure. Okay. Now, what will happen is, Ma'am Bindu, I know your name well, please. Okay. Same thing, Ms. Gitika, now what will happen if I need to apply this on zinc? Same thing will happen. 10 into this one, this into this one. So this 10 and 20 is repeating same number. So why should I do 10 and 20 again and again? Can I do it in this way? Is equal to SUMPRODCT, open a bracket, sum product. Can I 10 and 20, can I freeze it using a function F4? Comma, these two numbers, first of all these two numbers, I have frozen them, put a comma, then these two numbers, close the bracket and enter, and now what will happen, I can simply drag it down. Sure, all of you together, right? Okay. 25,000 was there and this much I am able to use. Can I introduce one more term, slack? What do you mean by the term slack? Is it okay? How much you have, how much you consume, the balance what you have. So is equal to this number minus this number, and similarly I can pull it down. Now what you are able to, so I have put my objective in place. Are you okay with it? In every problem, as I told you, you are required to identify what is your objective. You are required to identify what are your constraints. Ms. Anchita, right now I'm making 10 and 20. So you see that there is a lot of raw material still is available. So what will happen? I can increase more of X and Y. Again, I'll see that how much amount of slack is there. Have a certain amount of slack. There is a capacity for you to expand. But Mr. Mohit, now what will happen? How should I come with a number? Because every time I change these 10 and 20, all the numbers will get manipulated. There can be millions of combinations can be there, yes or no? Let me try. If I put any number over here, maybe if I put 30, if I put 50, all the numbers get manipulated, but still I have a slack with me. I can increase production more, maybe 60 unit of this, still I have a slack. If I make this 100, still I have a slack. So as I'm increasing the capacity, my objective is increasing, but what is my final objective? I need to maximize the profit, so that I want to identify what is the best combination I should use it. Is it okay? So that is why I am required to take a help of a tool solver. So what I do is, whenever you are required to play with the solver, the first thing is you should put your objective, your cursor on objective. Then navigate to solver. this window will pop up. Now, this window will come up. First one, whenever you put your cursor on objective and then go to solver, Mr. Vineet, one benefit will be there, then automatically this thing will get fitted into the target cell. If you don't do, then also it will work, but then there is a possibility that you may put all the constraint well and you miss out on your objective. So always put your cursor on objective and then navigate to solver. So first is my target. Are we okay? Next, I need to maximize or minimize. So Bindu. So I have a maximization. If the problem would have been cost, I want to minimize it. Next. Now, which are the cells I need to manipulate to get my answer? That is decision variable. So I'm giving a command that these are the numbers you are required to manipulate to give an answer. Now the system is asking that what are your limitations, what are your constraints? So I give then these two numbers, that is my consumption should be less than or equal to availability. Agree to me? My consumption cannot be greater than available, yes or no? Makes sense? Okay. There is no other constraint right now. It is a very basic problem, so there are no more constraints. But one more thing is there. You can see there is a tick mark over here. Right now it has come by default. But make sure that you put a tick mark here. Why tick mark? Because your x and y cannot be a negative number. Yes or no? Your x and y cannot be a decimal number as well. You cannot manufacture 50.5 bar tub. You cannot manufacture 60.8 bar tub. Are we okay? So right now I'm not putting a constraint of integer. I'll just leave it open. If I'm getting a full answer, well and good. If I don't get, then I can put a condition. Makes sense? Okay. Over there. I'll reset. So first I put my cursor on objective. My target has been chosen. Max and min has been chosen correctly. What are the changing cell? These are my changing cell. What are your constraints? In this one, both of them you can take simultaneously or you can take individually. Because right now the problem is very basic one, Mr. Pankaj. You can take both of the numbers together. So I select the two numbers. These two numbers should be less than equal to, you can see the notation, less than equal to these two numbers. Are we okay? Right now my consumption is for 60 and 100. Pardon, sir? No, no. So 60 and 100 are dummy numbers. These are random numbers. So I'm telling the system, I have put these numbers randomly. Now you change it. So solver will change it and give you the correct answer. Make sense? Add. There is no other constraint. Make sure that the numbers are positive. Last change. You can see it is a GRG non-linear. You'll have to use a drop-down function and use simplex. Now why this one? In the beginning only, as I told you, Mr. Anand, that there are two types of problems are there. One is a linear, non-linear. So right now it is a linear problem for you, because if one bar tub require 125 unit of steel, two bar tub will require 2, 3 require into 3. It cannot happen that you manufacture more with a lesser amount of steel. No. Are we okay? Sahil? Yeah, for at least for today and tomorrow, it will be by default always. But then as we go ahead, I'll let you know. Because if you are dealing in a risk, it is not essential that you will have a positive number, right? But in this, it is a manufacturing unit, so obviously you cannot manufacture negative. Make sense? So you don't have to solve, you have to just leave it here. Just prepare the equation, not to solve them. Yeah, usage is the same. Is it okay? X and Y I multiplied. So this answer should be less than this one. But this answer is only for a random number. Yeah? So then what will... Yeah, this has to be done. And all the numbers need to be connected. Otherwise it won't work. So Satish? Perfect, sir. Perfect. Yeah. Right, right. That won't be the correct answer always. No, sir, not at all. Okay. Let me solve, then I come to that one. Okay. Or shall we solve manually as well? Let us try doing both. First I solve. System, now you can see that system was able to solve the problem. System was able to solve the problem, and when you find that this is written and all the constraints of optimality are satisfied, means the problem has been solved well. Now I say okay. So the answer is you have to manufacture 200 unit of this one and 0 unit of this one. And at that point of time, your maximum profit will be 18,000, right? So Satish, I'll request you to just solve the two equations. One, five. Equations are right. Now, if we do a graphical method, let me do a graphical method. Is it okay? Let us try at least one. So just do a rough graph on the screen only. Hope everybody understood this one. I raised it. Yeah, sometime it will be, is it okay? It is a more profitable proposition because model A is giving you a higher amount of profit. That is the first thing. It is not essential that you are required to manufacture both the things. Sometimes it may be more profitable. Now I can put a constraint. I need your attention. Now what will happen, Ms. Anshita, I can put a constraint. Maybe there is a customer is there. He is a loyal customer of yours and he is asking 50 unit of B. You know that manufacturing B is not a profit, not a good proposition for you, but since he is your client and you are required to deliver, you can put an additional constraint that I need to manufacture 50 unit of B. I can do it, right? Let us try. But then definitely what will happen, Mr. Bindu, if I am forcing the solution, is it okay? System is telling that is the best one. But because of certain constraint, is it okay? You are required to manufacture B. Obviously, your profit will shrink down. Agree to me or not? Let us try. So, Mr. Kian, I am giving a condition to the solver that I need minimum 50 unit of B. So I add a constraint and I say that this number should be greater than or equal to 50. Minimum 50 I need to manufacture. Okay. Now solve. So what will happen? Now you are able to manufacture 50 unit of B, but definitely the profit is lower in comparison to earlier one. Are we okay? So Satish, if I try and solve this equation simultaneously, how you will do it? I need your attention for a minute. First of all, this one is known as inequality. An equation cannot be solved with an inequality. You are required to convert it into an equality. So my equation becomes 125x plus 100y is equal to, I am assuming 25,000. Then another equation is 20x plus 30y is equal to 6,000. So what will happen? Either if I multiply this equation by 2 and this equation by, so it will become 250. No, still it won't solve. anything. I can make this equation multiplied by 3 and this equation by 10. Are we okay? So this will become 300 and this will become 300. So then this becomes 375x plus 300y is equal to 75000. On this side I have 200x It's right, sir. So how much you are having? 175x is equal to 60. What is your x? Whatsoever number is it okay? Everybody got it? So you can check the answer. Is it okay? You will get an answer, but that is not an optimal one. Okay? Why it is so? Let us discuss that also so that the clarity is there. I'll erase this part. You will have to do it. I just wrote randomly, so I brought it. Mr. Mohit, please. Yeah, only maximizing the profit, but keeping yourself within the limitations. No, so that part we are not taken because right now this is an operation. So that part, is it okay if you have an extra inventory and the cost and all? That will go into the... Yeah. Yeah. Exactly, that will be there. So right now, because this is the operation part of it. So we are not looking into the financial profit, right? Anything you can do. Anything you can do it. I can make the question of this one as complicated you want. Any problem I can solve using the solver. No, no ma'am, no. At some point of... Okay. Ma'am Bindu, then I'll pause your question. Is it okay? Maybe some other question I take it. You'll find that it is more profitable, but still it is not getting manufactured. It may happen because it might be consuming some more amount of resources. Agree to me? All of you together? Shall we try one more problem before we come together on it? Okay? Ma'am Bindu, I'll take your problem then. I don't remember in which one this answer will come. I think we can get it in this one. Let us try. This is a course wherein you can get 100 on 100. This is the only course in entire EMBA program wherein you can expect 100 on 100. That's awesome. That's nice. Okay, let us try then. Shall we start? Shall we start one more? Okay. Manshita, was it okay for you? Because you just joined late, so I'm asking. Fine? Okay. Okay, let me do one problem more. I need that you come out of your laptop for some time, please. One more problem and then I won't. Mr. Shishi, only one problem, then 100%, then throughout the program I won't say anything to you. Because I'm not telling that I need exactly 50. I can put exactly 50 as well. Is it okay? You can do it. But sometime what will happen that exact thing doesn't work. Because after all, what will happen, you are consuming some raw material. Because of the combination, is it okay? Sometime exact may give that no answer is not coming. Okay? But in that case, see what will happen to manufacture a product, I require two raw material. Now if I don't have a zinc, I cannot use steel. Right? Ms. Yashash, please. Right. You have put in greater than equal to 50? No, better put greater than equal. Okay, just change it so that we can see. Shall I proceed to the next question? Let us try one more and then we will work together only. So I lift this particular part. Now, what is given to you in this one? Happy now, huh? Okay. Now, what is given? I need a kind request. Kindly come out of your laptop just for one question, please, all of you. Mr. Vineet, waiting for you. Ms. Avya, please, waiting for you. Are we all okay? Now, there are three products, are there, A, B, and C. A is giving you a profit of $12, B is giving you a profit of $15, and C is giving you a profit of $14. The language part I've eliminated, so it is understandable. So I write down that I need to manufacture a product A, need to manufacture product B, and need to manufacture a product C. First I can write down what is the margin or my profit. This is giving me a profit of $12. Next one is giving a profit of $15. Next one is giving a profit of $14. How many units I need to manufacture? I'll put it as a decision variable. Now, as I told you initially, what will happen? I don't know. So, any random number I can put in. And one more thing, we will follow a convention that decision variable, we'll not try and put it in a blue color. Is it okay? Just a convention. This doesn't help in any sort of solution. Yeah. So I put maybe 10 unit of this one, 20 unit of this one, 30 unit of this one, and I put this one into a blue color. Okay. Now, I have material A, material 1, then I have material 2, and then I have material 3. Three materials are there. What are these numbers? In order to manufacture 1 unit of product A, you require 3 unit of raw material 1. So 3 unit of raw material 1. Then how much amount of B require? How much? 5. And then we have 8. Next one we have 2. I don't require anything. Third one is 3. How much I require? 4. I require 6. I require 4. Are we all okay till now? Okay. How much availability is there? Availability is 720. 600 means max available, and this is 640. What is my consumption? My consumption, can I write down, is equal to SUMPRODUCT, open a bracket, some product of decision variable. Then I requested that it is better for us to freeze the numbers. I use a function F4, comma, then I select 3 numbers, And now simply I can drag it down. Makes sense? Mrs. Sanjeev, what will be the notation between usage and availability? Obviously your usage should be less than available. So I can use a notation. If I want to put a notation, it should be less than equal to. Okay. Can somebody help me in putting objective? Ms. Kshitija, can I request you to put your objective, please? Objective will be, you want to manufacture 10, it gives you a profit of $12. This gives you a profit of $15. So all the three numbers multiplied by three numbers respectively. Is it okay? So can I do it? Is equal to SUMPRO DUCT, open a bracket, sum product of these three numbers, comma, are you all okay? Right? No, sir, it's not about the less than. Is it okay? I will like to utilize the maximum possible extent, but in any circumstance, if I'm not able to use it, either less or equal. Actually, it is there, but by mistake, I couldn't put that sign. It is a mistake from my side. Okay, are we all okay till now? Ma'am Arva, are we ready? Okay, I put my cursor on objective, go to solver. So you remember, as I told you, that first you put your cursor on slack will become is equal to availability minus consumption, that is slack. Slack is some, is it okay? Tell us, slack is there means there is a potential for you to expand that way. But there might be some question that which particular slack or how much it is there, and that's all. So I put my cursor on objective, go to solver. First problem, as I told you, your objective should be rightly placed. Is it a max or a min? Maximization. What are the changing cells? These are my changing cells. Put now, start adding a constraint. Since I put all the things together, can I directly say that all my three numbers should be less than or equal to available? Make sense? Okay. It is already written non-negative. Make sure that you select this one as a simplex. All the things are feeded well. Objective is there, constraints are there, this is there. I say I need to solve the problem. Solver was able to find out a solution. All the constraint or optimality are met. The maximum profit which you can make is 2016. You need to manufacture 112 unit of A, 0 unit of B and 48 unit of C. Ma'am Bindu, now you can see this product was highly profitable, but still the system is telling don't manufacture. What can be the reason for that? What can be the reason? Though B product is most profitable, the system is telling don't manufacture it. Why? Less volume, yeah. See what will happen? The raw material which product B is consuming 5 unit of raw material 1 and 6 unit of raw material 3, right? And you can see that raw material 3 is a limitation for you. Because raw material 3 has completely finished 640. You have good amount of raw material B available with you. There is a slack. Slack means what? That you still have raw material, but you don't have raw material A and C. And B is the product which require good amount of raw material 1 and C. So system is telling that within this raw material of B, is it okay you can manufacture more of A and C? So the sum of profit of A plus C is greater than the profit of B. So it is better not to manufacture product B. All of you together? Makes sense? So now we know what is linear programming, what is non-linear programming. We know what do you mean by the term objective. We know what do you mean by the term constraint. We know how to use the functions SUMIF. We know the meaning of slack, and we know how to put the data in a solver. Are we okay? Right? Now all of you can do this problem. But first of all, you will have to bring the solver on your desktop. So I'll give you the instructions and we do it together. No, so solver can also put the term slack, which I'll show you in the third session. Yeah. There are a lot of tables are there now, which I'll show you in the next session. Mr. Kian is again getting scared of it. Huh? I'll put it. Ma'am, it is there on the blackboard. Mr. Vineet, for example, I want to manufacture 10 units of B. So I go back to solver, put an additional constraint. Then I say this B, I need to manufacture minimum of 10 units. More than 10 units, minimum of 10 units I am putting. Are we okay? Constraint is that this number should be minimum 10. Now you are able to manufacture 10 and your profit has come down to 1980. I bring the question back to normal first. It will come. If you, as I told you, if you don't get a message that all the conditions are optimality are achieved, if you give an opposite constraint, for example, Mr. Mohit, I'm telling you that you come and sit on this side. Is it okay? And Mr. Sanjeev is telling, no, you go and sit on that side. So what will happen? It is a mess for you. Where should you go? It happens. If you give a controversial condition to a solver, it cannot work. It will say that it cannot be achieved. Okay? I'll come to you. Okay, I will do it then. Ready? This side, Mr. Akhilesh. I'll do it then. Okay, what is there? A sweet fertilizer plant, smell fertilizer plant. You are required to make a fertilizer pack which require compost and sewage. So it require what? Compost. Now I can write down decision variable. First one, what will happen? How much compost should be there? I need your attention, 5 minutes please. How much? Maybe I put randomly 10 pound of this one and 20 pound of this one. I'm just putting random numbers. Since it is a random number, so I'll have to put it in a blue color. Okay, next. Each bag should contain at least 30 pound of compost but no more than 40 pound of sewage. First and second two conditions are there. Each pound of compost cost 5 cents and another one 4.1. So we can calculate the cost in the cent only. How much cost is there? This one is 5 cents and the another one is 4 cents. Okay. So what is your total cost? Total cost will become is equal to SUMPRODUCT, open a bracket, sum product of these times these. Are we all okay? That is your objective. Now I put my constraints. So I can, since I am working directly on the solver, I can put it there only. So I go to my data solver. 2 minutes, everybody need to be with me, please. 2 minutes. Okay, this is my objective. Janki, is it okay? Now, you want to min or a max? Minimization. What are your changing numbers? These are the numbers. What are your constraints now? This side. First of all, this number should be minimum how much? 30 pound. So this number should be greater than or equal to 30. This is my first constraint. Add. Not more than 40 pound. So now I say sewage should be less than or equal to 40. Second condition. Not more than 40. But I should have put in one condition more. So what I do is, only for 1 minute. It is saying that the total weight of the bag should be not less than 60. So weight can be written as is equal to SUM, open a bracket. Am I right? This is the weight of the bag. And this weight of the bag should be minimum how much? 60. So I put the third condition. First two are understandable. Mr. Satish, I add the third one. That this number should be greater than or equal to 60. Okay. Linear programming. Solve the problem. System is able to identify the ideal combination is 30 pound of this, 30 pound of that one, and the cost will be 270 cents. Make sense? I repeat it. So this number, Mr. Kian, compost should be greater than 30, minimum 30. Then I have sewage should be less than equal to 40 and the total bag of the weight should be more than 60. Kindly all solve the question together. Till we are not able to get an answer, all of us, we won't navigate to the next one. Should not be less than 60. Sir Shivakumar, shall I come? Okay. Which one, sir? That is the total of sewage and compost. You can make it or you can directly do it, no issues. Directly put it in the solver as well. No, sir. See, he is telling that the sewage should not be more than 40. If it is 35, then 30 and 35, 65 grams, 65 pound, right? Perfect. The another number, 7, fine, fine, right, right. Sir, I got your problem. Because sir, this is not a formula. This has to be sum of the two numbers, SUM. So for you, what will happen? You'll have to put one more condition because yours is the older version. Solve. So you'll have to click on options and say that there is a linear problem and non-negative. Always you'll have to do it. For them, they have them on the same sheet. Perfect. Greater than 30. Perfect. Equal to 40 and the weight should be greater than equal to 60. Yeah. Solve the question, ma'am. So Anand got the answer? So actually the weight you have to put a sum of these two numbers first. First cancel it. Close it, yeah. Sometimes what happens when we give a reverse condition somewhere, greater than 60. Only two. Okay, and got the answer? Okay, so Satish, you are checking.